Hi everyone, welcome. So as you already know, in this series Boost, we are discussing about most probable questions and important questions. This question also comes under that most probable question, and this question designed by me, and this question is regarding chemical bonding. If you have a conceptual knowledge, then you can do this question, otherwise you cannot do this question. Don't worry, I'm going to explain you this question in a very clear manner. If you feel that you don't have enough knowledge regarding chemical bonding, just go and revise once. Okay, you can definitely do this question again. Okay, so let us see what is the question. First of all, BrF5 molecule. This BrF5 molecule is given according to the valency shell electron repulsion theory. So I hope you people know regarding, you people have an idea on VSEPR theory, valency shell electron pair repulsion theory. So I don't want to explain again about valency shell electron pair repulsion theory, right? So according to the valency shell electron pair repulsion theory, so Br has NH2 NP5 configuration, 7 electrons. So 5 bonds is forming and 1 lone pair is there, total 6. So octahedral geometry and shape is square pyramidal. So square pyramidal geometry is already given. Square pyramidal geometry is already given. So options are theta 1 and theta 2 less than 90 degrees, 8 less than 90 degrees angles, theta 1 less than theta 2. Theta 1 and theta 2 less than 90 degree, 8 less than 90 degrees angles, theta 1 greater than theta 2. Theta 1 and theta 2 greater than 90 degree, 4 greater than 90 degrees angles, theta 1 greater than theta 2. Theta 1 and theta 2 greater than 90 degrees, 4 greater than 90 degrees angles, theta 1 less than theta 2. First of all, we see this. Okay, so what are the angles theta 1 and theta 2, whether they are 90 degrees or not? As you already know, adjacent bond angles are always 90 degrees, right? Adjacent bond angles are always 90 degrees. But here, if you see, if you observe the structure carefully, central atom is Br here, and F1, F2, F3, F4, F5, 5 fluorine atoms are there, like this. See, like this, 5 fluorine atoms are there, right? So if you observe here, if you observe carefully, this is F2, manlo, this is F3, this is F4, this is F5, right? Okay, so now this is the lone pair is just at the bottom. Okay, so this is the lone pair is just at the bottom, and one F1 is at the top. One F1 is at the top. Now what's happening? Actually the adjacent bond angles should be 90, but because of the lone pair and bond pair repulsion like this, because of lone pair and bond pair repulsions like this, these bond angles are not 90 degrees. All bond angles are not exactly 90 degrees. All bond angles are in fact less than 90. Why? What is the reason? See clearly see. First of all, lone pair is there here. So this F2, F3, F4, F5 are very near to this lone pair, and this F1 is far away from the lone pair, right? So now these fluorine atoms are experiencing more repulsions with this lone pair compared to F1. Yes or no? Compared to F1, these 4 fluorine atoms are experiencing more repulsion. So because of the repulsions, the angle between this F5 and F4, F2 and F3, F1 and F5, every bond angle is just reducing. That means we can say the angle is less than 90 degrees. So all bond angle is less than 90 degrees. According to that, option C is wrong and option D is wrong, right? Okay, so in among these two options, one will be your answer. Next, how many 90 degrees angles are there? Dekho. First of all, fluorine atom is there here, right? Fluorine atom is there here. So this fluorine atom is making bond angle with this F2, F3, F4, F5. So 90 degrees because it is perpendicular like this, right? So this is making 4 bond angles like this, 4 bond angles. Next, here 190, 1 less than 90, 1 less than 90, 1 less than 90, 1 less than 90, 4, total 8 less than 90 degrees. So in both the options we have 8 less than 90 degrees. Last one, theta 1 less than theta 2, theta 1 greater than theta 2, which is correct. See, first of all, repulsions are very high. These lone pair repulsions are very high on F3, F2, F4 and F5 compared to the F1. Yes, compared to the F1, repulsions are high. To reduce these repulsions, what happens here? These F2, F3, F4, F5 will just try to move away from this central metal atom. So the bond length will increase. So whenever the bond length will increase, the bond angle theta to bond angle will decrease. How? I will tell you. Simple explanation is this. I have an umbrella with me, right? So with this umbrella, if you see this button, okay, so this button is your, मान लो this is your F1, okay, so these spokes which I am showing here, these spokes are your F2, F3, F4, F5, right? So whenever the umbrella is like this, the angle between this button and this spoke is less. Yes or no? The angle between this spoke and this is less. So when I am moving like this, when these bonds are moving like this, that means these spokes are moving like this, right? When these spokes are moving like this, now the bond angle between this button and this spoke will be high. Yes, the bond angle between this F1 and this spoke is very high. So in the same way, whenever bond length is increasing, to decrease the repulsion, the bond length will be increased, because these fluorine atoms will try to move away to decrease the repulsion, so that the bond angle between this F1, F5 like that will increase, and this bond angle will decrease. Because of that reason, theta 1 greater than theta 2. I hope you people understood this concept. Okay, so like this you have to apply your conceptual knowledge to do this type of questions. All right, so if you have any further doubts, please ask me in the comment section. If you couldn't understand, please ask me. I will explain you again in my next video. Right, so that's all. Thank you so much.